This is a position of balance. These are just to hold this down because it'll be swinging. Move this up here. And then just come back here and just watch it swing. Notice how much it swings. No oil was used. And what this is an example of, it's there's linear momentum and angular momentum. Okay, if this were a complete wheel, then it's angular momentum. But with linear momentum, gravity would be accelerating this. So that would be, this would have linear momentum by gravity, and it's conserving it as angular momentum. Just, and you notice how much it swings with just easy slide. Oh, I'll provide some links for some of what I mentioned, but the net torque that's accelerating the wheel, that's linear momentum. It's being accelerated by gravity. That's F equals ma, or force equals mass times acceleration, and acceleration is distance divided by time. But then for the average balance of the wheel that's rotating, that is angular momentum. And when a weight moves closer to the axle, that is conservation of angular momentum. And with thermodynamics, they say the second law of thermodynamics says any system will suffer entropy. But when a weight moves upward, which is Newton's first law of motion, a body will remain in motion unless acted upon by an external force. And so this will have an external force moving the weight upward, conserving angular momentum. And so then the spin of the wheel is angular momentum. And with thermodynamics, the first law of thermodynamics states that energy cannot be created nor destroyed, but it can change forms. And so this would actually have a progression of 3 different forms, because on Besser's wheel, when the top weight is being lifted up, that's conservation of angular momentum, changing that weight to where it can also have linear momentum from the Earth's gravity. And since the Earth's gravity is an external source of energy, the second law of thermodynamics does not apply. This basic linear momentum, angular momentum, but one of the issues with linear momentum, or conserving it, it's like, see how it swings differently? That's conserving moment. It still has the same momentum when it swings changes. See how high it goes? But then down here. So this is something that in basic physics they'll teach you about. Because, I mean, right there, it's almost no trick to it. And one of the issues with a weight, if it rolls down a ramp like this, the length of the ramp divided by this right here, which in trigonometry this would be A, B, and C. But when the drop here is divided by this, that will show the time it takes for it to accelerate this much. It'll have the same velocity when it reaches the bottom here as it would here. That doesn't change. It just takes longer because it's going down the ramp. But it's, you know, the drop is what matters and not how long it takes to accelerate, because acceleration is slowed down by a longer path. And that just, you know, if you get into science and stuff and mechanics of motion, you'll learn about things like this.